How does a decimal point fit into this power of 10 puzzle? In general, a number with a decimal point is represented by a series of coefficients like a sub 0, a sub 1, a sub 2, and so on. And on this side of point it will be a sub minus 1, a sub minus 2, a sub minus 3, where these a is a digit from 0 to 9, and this subscript indicates the place value which determines the power of 10 that multiply with this coefficients. For example, we have 7392.34, and another way this can be written as 7300 plus 90 plus 2 units. So this is the way that we have 7000. So 7 times 1000 plus 3 and 200 plus 9 tens plus 2 units. 3 and 2 10 raised to power minus 1. So this shows us that 7 is multiplied with this one. So this 7 will be equal to a sub 3, because this 7 is multiplied with 10 whose power is 3, and this will be equal to a sub 2 because this is multiplied with 10 whose power is 2, and similarly this 3 will be equal to a sub minus 1 because this 3 is multiplied with 10 whose power is minus 1, and this 4 will be equal to a sub minus 2 because this 4 is multiplied with 10 whose power is minus 2. So we can say that this is the coefficient a sub 5 gonna multiply with 10 whose power is 5. This a sub 4 gonna multiply with 10 whose power is 4, and this a sub 3 gonna multiply with 10 whose power is 3. So this base or subscript will be equal to power of 10. Alright, similarly this a sub minus 1 gonna multiply with the 10 whose power is minus 1. So this is the way how we have to use this. So this allow for both whole numbers and fraction in one system like this one. So the decimal point separates the positive powers like we have over here. We have a point over here, decimal here, on left, from the negative powers on the right. So we will have positive powers of tens on left of point and negative powers on right of this decimal point, making it versatile for precise measurement. This is why we call it base 10. Let's define that next.